Shep, glad to be here. And yep, I'm going to talk about economic injury levels, how this can apply to decision making for crops. And then I'll move into talking about a few different topics, such as sampling methods and how we can use those for pest management when it comes to vegetable crops and other crops as well. So to start out with, when I think of economic-based decision making, a lot of times we think about the word sustainable. And to me, that means a number of different things. It's hard to have sustainability without profitability. And so we need to think about sort of the short-term dynamics of what we're dealing with, but we also need to think about that long-term as well. So, for example, if we're making decisions for this year's crop, there might be carryovers into the next crop we rotate or into the next year as well. So, really taking all of that into account when it comes to pest management is important. Environmentally sound, thinking about uh, both our field, but then also what's next to our field. Those things can matter, but in general, I think we need to have a system approach. We need to think about everything in tandem together, but also consider that we need to be dynamic. When we're talking about economics, a lot of times we say that, it depends. That's the answer to everything. And a lot of things just change. Prices change all the time. The tools available to us change all the time. And so being able to take into account new things we have to our disposal will really help us as managers. And so one thing I always like to point out when we're talking about economic-based decision making is that highest yield doesn't always equal highest profit. And so, quick example, let's look at a corn crop, for example. Let's say yield is 65 bushels per acre. We're facing a price of $5 per bushel. So our total revenue for that crop would be $325. Let's suppose that's if we apply fertilizer, NPK, at $80 per acre. And so if we look at our net revenue or revenue minus our fertilizer cost, that would equal $245. In contrast, let's say we could cut the phosphorus and potassium and just apply nitrogen for $45. Now, this would result in a yield decline of 5 bushels per acre. So we're now at 60 bushels per acre. Our revenues would then be $300. And after subtracting our fertilizer costs, we're looking at a net revenue of $255. And so we cut our costs here by $35, which resulted in a yield decline, but we only cost ourselves $25 in revenue. So in essence, what we're looking at here is that the amount of savings we had were $35, but the amount of additional of lost crop revenue was $25. So it makes us overall better off by $10. And so, just looking at yield in this case wouldn't maximize our profit. So it's one of those things we might want to take into account. Now, I mentioned, highest yield doesn't always equal highest profit. This applies to pest damage as well, when it comes to applying other inputs. So for example, insecticides, it might be, labor costs for some of these things as well when it comes to removing pests and even looking at how much pest damage exists. Um, but, going back to the last example, profit is an important consideration, but it might not be the only consideration. So for example, if we're worried about subsequent years, we might want to consider adding phosphorus and potassium because of that carryover effect, even though if it's not necessarily the profitable decision for one year. So overall, it's important to consider all of these different aspects in economic decision making. Now, pest management actions must be economically sound. We often need to think in advance. So before an anticipated pest problem occurs, our pest populations need to be suppressed to prevent or minimize economic losses. And so the timing is really important in this aspect. And our decisions need to be made to prevent significant economic injury. And so I'll talk more about what some of these terms mean, especially the idea of economic injury. And so when we're talking about pest management, really we're talking about the practical manipulation of pest populations using any or all suitable control methods in a compatible, ecologically sound manner. And so, we have a lot of tools at our disposal. Our goal is to reduce pest population. We care about the damage that's economic damage. So, we might have pests that cause that are in our fields that don't actually result in economic damage. So from this standpoint, that's not what we're concerned about. We're concerned about the ones that usually affect some sort of marketable yield. Now, our goal is to reduce the pest population by applying different suppression techniques. And we want to use a diverse combination of the management practices available to suppress pest populations. We don't necessarily just want to use the same tool over and over again because over time it might become less effective as those pests build up resistance and um, things like that. And so thinking about everything we have available to us, being able to use all of those is an important concept in pest management. So we want to consider the effects of different techniques. Usually there's going to be some trade-offs. Some might be more effective but more expensive. Some might take more time to use or just be inconvenient, but be cheaper. And so there are different times and places. When I talk about pest populations, a lot of times we need to take action quickly. So sometimes spending more money for something that's more effective or uh, takes action quicker might be the best method, but that's not always going to be the case. So it's important to, talk to the people we have, the extension agents who have good knowledge on, how bad a problem is, to know what the best method in a certain time might be as well. It's also really important, I'll always mention this, but applying the correct chemical at the correct rate and the correct time is critical for effective pest management. We don't want to be applying products, not in the best way. Sometimes that just results in a waste of money. So making sure we're, spending money in the best way possible to have the best desired results is important there. So when we're talking about reducing pest populations, the big question is why? Well, in this context, we're worried about the economics. And in that point, we're concerned about the economic threshold. And that really tells us when to treat. A lot of times if we're listening to entomologists or plant pathologists talk, they'll talk about the economic threshold, and that's where this comes into play. The idea of when to treat depends on several factors, and I'll talk about those in a minute. One of those big factors is prices, which really affects a lot of our decisions. So the economic threshold, um, the decision to treat or not treat is based on the pest population in relation to that economic threshold. And the economic threshold is the population at which control measures must be taken to prevent economic loss. And so when we say economic threshold, we can think of the action threshold. That's the point where we need to do something. Otherwise, the pest is going to cause economic damage to the crop in question. Now, economic thresholds, a lot of times we set them based on research, but it's important to consider the value of the crop matters as well as the cost of control. So for example, the corn example I showed earlier, where the price of corn is $5 per bushel, and our yield were 60 bushels per acre, we're looking at $300 in revenues per acre. If the price of corn goes up to, let's say, $7 instead, that's an additional $2 per bushel, or an additional $120 per acre. So if corn is worth $120 more, we're going to be more willing to save any corn from being damaged. Whereas if corn price is lower, we're going to be less willing to take action. So those are just some examples of how prices affect the economic threshold. So looking at it visually, this S-curve of pest population graph on the right shows, so over time, the pest populations increase in a logarithmic manner. And so this economic threshold is the point where we would need to enact some sort of control to prevent them from reaching this increase shown there. So in essence, we can say the economic threshold is where control is necessary to prevent economic injury. Now, what is economic injury? That's the lowest population density of a pest that will cause economic damage. So if we're below the economic injury level, that means we don't have economic damage. We have the pest present, but it's not causing any damage to our profits. However, if we reach that economic injury, that's the point where we do start to have that damage. And so the amount of pest injury is what really justifies the cost of controls. And so as we think about this, there's 2 points we really need to think about. What is the cost of control? How much does it cost to prevent economic injury? And secondly, what is the cost of the damage? What is the cost of the economic damage that the pest would cause? And so putting economic injury on that prior graph, here we have, so again, we have our economic threshold here, that orange dashed line. That's where we need to take action to prevent economic injury. And if we don't take action, economic injury level, that's when we start to have damage. And that's when the cost of our damage is equal to the cost of control measures. And so if we go up to a high population in general, we're going to say that's where the damage that the pest causes is greater than the cost of control. So that's where we definitely want to make sure we're controlling our pest populations. Whereas down in this low area in red, the cost of control is usually more expensive than the damage we're trying to avoid. And so that's where we're less likely to want to take action um, in relation to pest management. So another way to put all this is with this graph here. I like this one because it shows the economic threshold. So same on the vertical axis, we're looking at our pest infestation level, and horizontally, we're looking over time. So as over time we go, we reach our economic threshold. So remember, that's where we need to take action to avoid economic injury. Let's suppose we don't do anything. So we're without control. That's when our pest populations continue to increase. They reach our economic injury level. And so we incur economic damage in that case. And they continue to increase and then eventually they'll subside. But it's after they've already caused economic damage. In contrast, if at the economic threshold, the action threshold, we do take action and we put in our pest management tools, that's when our pest populations will decline and then they'll increase again, but they will never reach that economic injury level. And so since we didn't reach that economic injury level, that's where we were able to prevent that economic damage. So looking here, this is our economic threshold level. This depends on a variety of factors. So there'll be times where the economic threshold is lower and times where it's higher. So let's look through some of those examples. And so if we're looking at a relatively small amount of damage, so if damage is not tolerable or we're dealing with a high value crop, that's when our economic threshold is going to be lower. In other words, going back to this previous diagram, we're going to have to take action sooner to prevent economic injury when the economic threshold is lower. In contrast, if the economic threshold is higher when we have a crop that can tolerate temporary pest damage without major changes to yield. So for example, if we're dealing with a crop that's more resilient to the pest, we don't have to take action as soon. So if we're dealing with a crop that is a higher value crop, and that's a lot of times when we're looking at our specialty crops, fruits and vegetables, or damage not being tolerable. So if we're dealing with a marketable crop, for example, tomatoes, if there's damage to the tomatoes, that's going to decrease its marketability, whereas that might not quite be the case for a crop like cotton or corn to that same degree. And so those are things that are going to affect the threshold level. And these economic thresholds are set for, all sorts of different pests for all different crops as well. So factors that raise the threshold, if the aesthetic level isn't important, so for example, filled corn or hay, that's going to raise the threshold. We're less likely to take action. If pests are not an issue, um, in general, this is going to raise the threshold as well. If we have new varieties that are more resistant to the pest, that's going to raise the threshold. Alternatively, if some factors that lower the threshold, if aesthetic level is important, so if we're looking at tomatoes, apples, most of our fruits and vegetables, floriculture, those are all going to lower the threshold because that aesthetic level is vital. If we have a highly sensitive crop or a high value crop, those are going to lower the threshold. And so important to note that these are all things that could change during the growing season. You might start with a crop that is has a high price that goes to a low price or vice versa. And so important to consider how these can all change as we go throughout the year. So quick example, if we have a soybean field that has kudzu bugs shown in that picture, we might have a cost of control might be $20. So if we want to prevent there from being economic damage, and let's suppose that spending that $20 would then prevent 2 bushels per acre in yield damage. And let's say, for example, the soybean price were $8 per bushel. So the question is, do we take action? And so what we can do here is compare the cost of damage versus the cost of control. And so the cost of damage in this case is the 2 bushels per acre of yield damage we're trying to avoid times the $8 per bushel price. So the cost of damage would be $16 per acre. In contrast, the cost of control is that $20 per acre we have there. And so in this case, the cost of damage, we're looking to save $16 per acre by spending $20. Not worth it in this case, so we wouldn't take any action. Now, if the soybean price increases to $12 per bushel, the cost of damage goes from $16 up to $24 because now our 2 bushels in soybean loss is worth $24. And the cost of control still stays at $20. So now we can spend $20 to save ourselves $24 in losses. That's worth doing. And so we take action in this case. And so the increase in soybean price reduced our economic threshold. Now, if our input costs decrease, so now instead of our cost of control being $20, now it decreases to $12. In this case, we would take action. And that's because to save that $16 worth of damage, it costs $12 now. So it's worth doing so. And now the economic threshold is lower. So in general, if our product price increases, our economic threshold is going to decrease. And that's because the cost of damage is higher. If our product price decreases, then the economic threshold increases. That's because the cost of damage is lower. If our cost of production increases, the economic threshold increases. And that's because the cost of control is then higher. And then likewise, if the cost of production decreases, the economic threshold will decrease. And that's because it costs less to control the damage. So, for example, if the price of a crop increases, would this raise or lower the economic threshold? In general, this lowers the economic threshold because the cost of damage increases. Now, another example, suppose that the price of an insecticide used for treating a crop were to decrease. Would this raise or lower the economic threshold? If the price of a pet insecticide decreases, then we're more willing to control, so this lowers the economic threshold. And then another example, suppose that a plant's resistance to a certain insect increases. Would this raise or lower the economic threshold? If a plant's resistance increases, then this would raise the economic threshold because essentially the cost of damage decreases in this case. So we talked about the economic injury and cost levels. a big question is how do we actually come up with those levels, both for infields, so for management decisions, but also for research for coming up what those economic thresholds are. And so that's where sampling comes into play. Before we have the anticipated pest problems, we need to be able to suppress them to minimize our economic losses. And we can't see ahead what's going to happen, but by periodically sampling, that's when we can start to know where we are and how we can move ahead to combat the issue. So we use periodic sampling procedures to correctly time pesticide application. It can tell us what methods we need to use and when to apply them. Oftentimes, our pest management revolves around having accurate assessments of our pest densities and plant damage to be able to know what the effects on yield will be. And so, if we're talking about sampling for research, we need really precise estimates to be able to enact what those economic thresholds are. But if we're sampling for management, we really need rapid classification. We need to be able to make quick decisions on the farm. And so when we're talking about sampling, there are three different groups for estimating population densities. The first one is absolute methods. We have relative methods, and then we have damage assessments. So absolute methods, these ones are sort of that best case scenario, what we're really looking for. They give data density per unit of land. And so as researchers, this is what we most often want. But they are timely, are time consuming, and they do take a lot of effort to get these. So oftentimes it might require counting pests that are present in the soil, the litter, soil surface, vegetation, and even in the air. So takes a lot of effort to be able to get an absolute method. And that's because our goal is to count every single individual in a unit of area. So we might be looking at every of a certain insect that's on a plant or within a meter row or within a larger area. And so being able to do that, takes a lot of time. And so that's the main disadvantage is the time and labor required to process the samples and even just collect the specimens in question. Second, relative methods. Now, the goal of a relative method is to capture a consistent portion of the total population. So, in contrast with absolute methods, we want to capture every single unit of the population. With a relative method, we want to capture a proportion. And so, oftentimes, if we're looking at, an entomologist might use sweep nets or insect traps as common tools used as relative methods. And so, these ones are relative methods because the proportion of insects caught, it's going to depend on the efficiency of the method. Behavior of insects matters a lot for how effective these methods are, and then the life stage of insects as well. If they're large enough to be caught by a sweep net, for instance. Now, the advantage is we can get more data with limited labor and equipment. So if you're dealing with several acres of crops and you want to be able to look at different areas of a field or even a larger field like several hundred acres of cotton, you can use these methods to be effective there. They are able to do so really quickly. Now, the disadvantage is that data collected can be misleading. And so we need to take into account that um, we're not using an absolute method, that this is a relative method. And so we can compare within a field, maybe the differences of an outbreak, but we can't necessarily say what that means overall. Lastly, damage assessments are determined by, are able to determine the amount of damage caused by different factors. And so the amount of damage depends on several different things. One would be the pest density, second, the behavior of the pest species, and then biological characteristics of the plant. And so those are all things we need to consider when we're looking at the amount of damage. And so We use damage assessments often to define the economic status of given pest species. A lot of times we use them for the economic assessments for stuff that's already happened in the past. For example, um, recently fall armyworm outbreaks, damage assessments used to determine basically what was the economic status of the outbreak and could be used for governmental program reasons as well. We also use damage assessments to establish the economic threshold and injury levels. Um, those ones, as I showed that graph with the essentially what's the control measures taken into place, what happens for a pest population with and without control, that's an example of where a damage assessment fits in. And so we want to be able to estimate the effectiveness of control measures, but also see whether certain crops are resistant to new varieties. And so when we're looking at damage assessments, there are two main types of rating systems, objective and subjective. And so objective measures can be used on any type of damage that can be precisely measured. So oftentimes we're looking at percent defoliation, percent germination, percentage of plants that are deceased, the number of dead plants per row, how many weeds we have per plot, per row, per acre. Usually it's some units of measure like that. So if we see a count, a percent, or an average, that's usually going to be an objective rating. Uh, a subjective assessment is based on visual evaluation, and so it's going to depend more on the experience of the person rating to assign values on the degree of damage. And so a subjective rating might be variable among a different people. You could call in some experts to give assessments, but they're going to be rather rapid methods. So, for example, a lot of times we do stuff with drought. And so being able to classify, um, whether drought's occurring, sometimes we use subjective measures like that, combined with some objective ratings as well. And so if we see something like low, medium, or high, that's going to tell us that we're dealing with a subjective measure. So as an example, if a researcher counts the number of aphids on a strawberry plant, would this rating be subjective or objective? Since we're dealing with a count, usually going to be objective there. In contrast, if the conditions of plots on a research farm are evaluated as good, fair, or poor, is this system subjective or objective? This one would be subjective because there might be differences in how evaluators would deem the plots to be. And so if we look at apples and we're looking at their marketability, this one would here be a subjective measure if we're not dealing with any sort of a test that can give us a number on essentially the marketability there. And if we're looking at percent crop damage evaluated through some drone imaging, this would be objective if we have a program that can tell us the percentage of crop that's damaged using some sort of a measure there. And so when we're talking about damage assessments, there are a few complications to take into account that might underestimate the amount of damage that we're measuring. So, for example, we might have various types of attacks by complex pests, whether they're affecting, the fruit portion of a crop or they're affecting the non-marketable portions. That's something to consider. We also might have some crops that are damaged and neighboring plants that aren't affected that might produce higher yields. And so the undamaged plants, if they produce compensatory yields, how do you account for that with regards to the damage that occurred to the one pest? So that's something to keep in mind. And then I'll talk about direct versus indirect effects of pesticides. And so when we're looking at pesticides direct effects, those involve things that can be counted. So usually we're saying that's when it does damage to some marketable yield. And so it's relatively easy to correlate the damage level we have to the yield loss. And so, for example, if the picture I showed before with the apples, that's an example of a pest doing damage to marketable yields. Whereas if a pest does damage to the tree, um, that would be an indirect effect because it doesn't affect the marketable yield. And so indirect effect when the pest damages a portion of a plant other than the marketable portion. And so that the challenge with indirect effects is we're less, it's harder to be able to necessarily correlate the damage to yield loss than with marketable where we can have show what was produced, but the damage that exists to it. Now, when we're looking at the plots that we can use for damage assessments and other sort of methods to understand what our economic injury levels are, we can use either research or demonstration plots. And both of those are useful. They just have some differences. But they can both be used for application methods, understanding the effectiveness of pesticides, how when we need to apply it, the correct timing, and being able to study all these factors. Now, with a research plot, we typically have a more rigorous design. We have replications for data collection. We're usually using statistical methods to evaluate, whereas demonstration plots usually not replicated, but can still show those economic injury levels and understand different courses of action and how they affect pest management. With that, I want to thank you all for your time on this presentation on economic injury levels and thresholds. And if you have any questions about those, I'd be happy to take those now.